Welcome back to part two. Sorry I got cut off in that one because the recording software only lets me go for 10 minutes at a time. Bit of a pain. Here we can see we're back at synthetic division. And so it'll ask the degree of your polynomial and then uses arrays, just static arrays with degree plus 1 because, that's how functions are. It's like if the degree is 1, it's x plus a constant. So it has to be the degree plus 1. And then we can go down, it'll ask for the divisor, and that's just the number connected with x. So if it's x plus 1, there should be negative 1. And then, then it'll just loop and ask for each coefficient, and put that into an array. And then it'll set the first one equal the first portion of the array is the first polynomial coefficient. That's just the way synthetic division works. You bring it down, then you'll multiply it by the divisor, and then you'll add it to the next coefficient. So you can see that in the for loops, where you have the answer I is equal to the divisor times the answer I minus 1 plus the coefficient. And then it'll just print them out. And that concludes it. And it prints it out in here just so you don't have to send every single one back. That'll be a bit of a pain. But then we can move down and we can see how the graphing functions work, where it'll print out the function, and then it'll get all your information in that function, and then it'll do the iterations, where you want to start, and a change in x. I have delta x, that's just how I am. But then it's pretty simple. You just have y naught is equal to the function at x naught, which is just x, to start, and then the pen will just move from point to point all the way through. So it just has y equals that, and then x will just increase by the change in x, hence why it's called the change in x. And that'll go for as long as the change in x times the count plus the original x value is greater than x, right? And it does that for all of them. So you can see that's just a really simple thing. It's just right here, it has to just make that small adjustment to go from linear to a power of 2 by doing math.pow x2. And then down here, it just gets even longer. And that's why it only goes out to cubic functions. And that concludes every single thing included in here, at least everything relevant to how the program works. Thank you, and enjoy.